Thank you very much for that very generous introduction. Hi everyone. I thank you for spending time with me here today. This is going to be somewhat different, I guess, from most of the talks that you've heard so far. The approach is the same, but the subject matter is kind of out there. But the one thing that I will promise is that it's going to be interesting, and I hope you learn about new things or get a new perspective. This talk is focused on low-code, no-code applications. Before I dive into what those are and what are we specifically going to see in this talk, this was already covered, but I've been working on the intersection of low-code, no-code, and security for the last 4 years now. And most of my work goes to an OWASP project that we have started about a year ago, top 10 for low-code, no-code. We've been we're fortunate to have other people join us from Microsoft and Palo Alto and other companies. If you're interested, we are right now looking for contributors. There's a meetup in a couple of weeks, so reach out to me or check out my Twitter. There's an invite there. Okay, this talk is given, of course, from an attacker's perspective on low-code, no-code, but it's important to note that we're all for low-code, no-code. This is these kind of technologies, putting more power in the hands of business users, is something that we've been trying to do as an industry for, I don't know, for just too long. And this is actually going on, this is actually happening. So business users are actually building their own apps. You'll see that in a moment. And so the idea behind this, of course, is to help us as security professionals and help the business do this in a secure way. Here's what we're going to do today. We're going to start with understanding what low-code, no-code applications are, and the idea behind it is just to make sure we are all on the same page. After that, we'll go into basically how low-code, no-code is being attacked, or how attackers are using low-code, no-code in the wild. This is all based on real attacks that we've observed in large organizations, mainly large US enterprises. We'll see a whole bunch of attacks living off the land, other attacks, you'll see them in a moment. We'll, of course, finish off with how to defend yourself and what you can do to basically take this further as part of your red team arsenal, and also as part of kind of internal evangelism you can do in your organization. Let's start with low-code, no-code. And before I go to what specifically low-code, no-code is, the reason why it's important, and maybe the most important slide in this talk, is the following one. This chart represents one organization, one Fortune 500 organization, and you can see the number of low-code, no-code apps developed in that organization within a few years. This chart is really why this talk is important, why this subject is important, and why we as security professionals must be part of the low-code, no-code conversation. These numbers are, of course, anonymized, so I won't tell you the company, but they are real. And they are not an anomaly. We see this again and again with large organizations. So the Fortune 500s would have close to 100,000 applications, and the smaller organizations, like a few thousand employees, would have tens of thousands of these applications. Keep in mind, these are small applications. You can call them, I don't know, micro apps or something like that. They can be like an if this then rule, or a small widget application, but they still have identity. They still access data, so they have the same kind of threats. This, again, is why it's important. And the other fact that most of you in this room are probably aware of, this is, in most cases, not where most of security professionals spend their time on, right? This is not where we focus our time. We focus on professionally developed, on pro-code applications or applications built by developers, but business users are creating many more applications. And it's about time we get involved in that discussion. Okay, low-code, no-code, this is basically why it exists. So the reason why people are using it. Of course, IT cannot cover all of the needs of the business. And business users are really tired of waiting around, and they want to solve their own problems. This is actually not new. So we've had multiple instances of trying to do just that. And by the way, we've also had success. So Excel, for example, is a great example of empowering business users, right? This is probably the one tool I've been using throughout my career, no matter what I've been learning besides that. But you can see like a technology that was used in order to empower business users across this vertical. You'll find that some of these technologies are also our close friends as security professionals. For example, macros. We are still having fun with those. And so today, low-code, no-code is kind of the latest iteration on this trend of empowering business users, decentralizing IT, putting more power in the hands of the people that they can actually move the business forward. Low-code, no-code applications, and by the way, I'll be using low-code and no-code interchangeably here, and if you and we can go into in the Q&A on how those differ or if they differ. These are a few examples of what low-code, no-code applications are actually doing. So there are automations. For example, if I get an email with this thing in subject, then create a ticket in Jira. There are integrations. So integrations or automations, you'll find typically business applications team or automations teams that are plugging in SaaS and on-prem and everything together, stitching things together. There are business applications, mostly to facilitate business processes. So for example, you want to get reimbursed for expenses you make on this trip. You'll have a mini app that would allow you to upload those receipts and get those returns. There are entire products that are built with low-code, no-code. This is relatively new, but this is happening. So people are creating startups with low-code, no-code as their front end. Enterprises are building user-facing, consumer-facing applications with low-code, no-code, which is really cool. And of course, mobile apps as well. There are really, you can really do anything with this. And this technology is right at a stage right now where it's actually been used by these enterprises for many years now. So for not many years, but for 2-3 years now. And some of these applications have become business critical, which is why we're having this talk right now. Because of course it means that attackers are looking after them, are looking kind of at them, and we should be too. We should be doing that too. I'm sure one of the questions that you have in your mind right now is whether this applies to you. So to you in your specific organization, with the tools that you're using. And one of the things I wanted to tell you today is that it probably does. Even if you don't know it, it probably does. And the reason behind it is that low-code, no-code finds its way into an enterprise, into an organization in multiple ways. Of course, there are some organizations that are going all in on low-code, no-code. The CIO or somebody in digital transformation would say, this is what we're going to do. And we're seeing this in multiple organizations. But for the rest of us, if you're using any one of the services here on this slide, or any other major SaaS vendor, you have low-code, no-code already in your organizations. Because these vendors are basically using low-code, no-code as a way to expand from something that is solving a specific need to an application development platform. So consider Salesforce, for example. Once upon a time, you could be thinking about Salesforce as a CRM. Today, that's nonsense. Salesforce is a cloud. It's just a business cloud with different kinds of applications, but it's closer to AWS, Azure, and GCP than it is to a CRM. And that's the main point here. You see, if you're a Microsoft shop, you have a large low-code, no-code platform already embedded. I promise you, people are using it, and others as well. And so this is really everyone's problem. So a quick recap before we move forward. Low-code, no-code. Is available on every major enterprise. It has access to business data and business processes. Well, the reason behind that is that when you looked at the logos before in this slide, these logos are they also have our data, right? They also have the sensitive business data. And so low-code, no-code applications are built on top of that sensitive data. They run as SaaS. So this means that forget about VM monitoring or network monitoring or any of those. And to my point earlier, they are underrated by IT and security in most cases. And this is kind of the premise of why we believe it's important to for us to get involved right now. So what I'm going to show you, so we've gone through the kind of low code in a nutshell. We understand what we're talking about right now. The next part, the meat of the talk, is going to be actually talking about specific attacks that we've seen in the wild. If you're interested, I'm not going to tell you how to detect those attacks. If you're interested in that, check out the OWASP project. So OWASP Low Code, No Code Top 10. Before we move to see specific attacks, what I would like to do is show you a concrete example of a low code application or a no code application, and I'm going to create it just so you can see how easy it is, and so we all understand the same thing. So hopefully this works. Okay, there's this annoying thing in Slack where when somebody mentions you on a public channel, you get this pressure to respond quickly because people are seeing. So I'm creating here a very small automation that does a simple thing. Every time I get mentioned in Slack, it will change my status as if I'm on a call. So the person will kind of know not to bother me. And then a few minutes later, it's gonna change my status back to be free, so nobody would be suspicious. And you can see that I'm doing this step by step. This is, of course, a silly example. But it shows you the power of what's actually happening here. One thing to note is that in no way in this demonstration, I'm not authenticated to Slack in any way. We'll cover that in a moment. But you can see that I'm dragging and dropping. I'm choosing parameters, like, for example, the status code that I'm on a call. This is something that is kind of really easy to do. And the interesting thing behind it, think about, so you'll see in a moment, okay, I'm done. When I'll be done, I'll click on that publish button, and that's it. The application will be published and operating. A few things to note here. One is that this is a pretty complex piece of software. It authenticates to Slack. It needs to somehow maintain that secret. Maybe it needs to roll it. It needs to subscribe to a webhook on the Slack side. It needs to support APIs and their changes. There's a delay step because you need to wait 5 minutes before before I change between status changes. So it needs to be kind of running somewhere. This is a significant piece of software, and you'll see in 30 seconds it will already be ready. And I didn't do anything sophisticated there as a user. This is specifically an example from Zapier, which is a tool that is focused on actual end users, and people are using this. People are using this a lot, and this is also why you get so many applications, just because it's very easy to create them. So I was alluding to the authentication part here. One thing that you should be asking yourself is, how is this thing running? What is the identity behind this application? When it connects to the Slack API, either through the webhook or through the API later, who's actually making those calls? And so here's the answer. When you create this application, the first thing that you need to do is to pick an application you want. So inside of Zapier, you need to pick the application you want to work with. For example, here, Slack. But in all of those platforms, there are hundreds of connectors that connect wherever you'd like. It could be SaaS, on-prem, through gateways, wherever you'd like, really. And then the first thing you're going to do after you click on one of them is you're going to connect. And this will be a familiar OAuth experience. So you get the OAuth pop-up, you see a bunch of things that Zapier wants to do with your Slack account, you say allow, and something magical happens. They create an object called a connection. This connection is essentially a wrapper around the OAuth refresh tokens. What they also give you for that connection is a nice little share button. What does this share mean? It means that you can share your wrapped up refresh token with another user. And that's how these platforms operate. This also means that from the Slack perspective, from the network perspective, from all of the existing tools that you have, from all of those perspectives, there's no app, there's no share. This is one user reusing their token again and again from multiple locations. This is a fundamental flaw in the way that this technology works. It is consistent across platforms, And by the way, the reason behind it is that this is not only a flaw, it's also one of the reasons why this works. Imagine if you wanted to have this graph of so many applications built in the enterprise, but you had to ask for permission for each one of these applications to create an identity for that application. That would never happen. You'll never see that exponential graph. The reason why you have that exponential graph is because you can embed your own identity in those applications. Okay, so that's the good part and the bad part about it. But it also shows you why I was able to create this application before in the demo. I just created this connection beforehand, or I could have just picked up that connection that another user created and just reused it. Okay, so this is actually, I've kind of explained this, but just to make sure we all understand, when we have the application on the left side and the API on the right side, and essentially there's, and this is actually a picture from Microsoft documentation, there's basically a reverse proxy, a proxy that sits between those two, and it dynamically changes the token when the request goes to the underlying service. And so they are able to inject the token, the refresh token, so the user never sees the actual token. They don't understand that they're sharing a token. They're sharing something called connection. It looks nice. There's a nice little button then to share. So this is how it works. And when you look at these platforms, you get, because it's so easy to create applications, you get a lot of applications. These are specific examples from marketplaces of different vendors. So these are all things that people are just picking up and using. And you can see the most important thing about this slide is actually the logos. So because they indicate where the data comes from, what data these applications are touching. Behind any one of those logos, there's business data or there are business operations. And so behind the tens of thousands of applications that you saw earlier in the chart, there are at least 10x more connections. Connections are refresh tokens that are just there on the platforms. And so when you go to these platforms and you kind of look for those connections, you'll find hundreds of those connections. And one of the things that is common about these platforms is that they have some notion of a default environment, a way for you to share those connections, not only with one user, but with everyone in the organization. And again, there's a reason behind it, because you want to empower people, you want to let them work fast. And so if you go to the default environment in your Office 365 instance, in Zapier, in Workato, and in others, you'll find all of those connections ready for you to use. And so, of course, this is just credential sharing as a service. This is just built-in credential service being facilitated by those platforms. And for us to identify that, there's no real way to do it through network mechanisms or through monitoring the authentication itself. It's only through those platforms. After so this is one thing that is very common. So we see attackers using these default environments to just gain all of those credentials. After you just get access to those credentials, the next piece is, okay, what do you do with them? Well, so you can do easy things like ransomware, for example, with a drag and drop. This is very easy. So I go to a specific SharePoint site, I list everything in that SharePoint site, and I encrypt it with a useful encryption function that is provided by the platform. Okay, and this is an automation. This is not a one-time thing. I can do this. This continues to run. So this is one kind of nice example. The other example and this one I think there was in any organization that we've worked with, this one reoccurred. This is a great way to exfiltrate data outside of organizations, right? Because you have, for example, to make sure people are not forwarding business email to their personal Gmail, you have a bunch of things that are preventing that, right? You have things on the client side and on the email server and DLP and many things. So people have found out a new way to bypass DLP. They simply copy the content of the email from one email to another. So the automation is subscribed to every new corporate email, and then when it arrives, they create a draft on their own personal Gmail account with that email. And so there's no real way to know that, again, from the email server, because the content here is being copied. And of course, this is one example with emails, but this happens with files and drives and everything else. So that's a very common example. Let me go into another one, which is a bit less trivial. These platforms also allow you to jump to people's laptops. And this is because low-code, no-code also has a component called RPA. In some cases, it's kind of a different thing, but still, RPA is an automation that runs either on servers or on people's laptops, on their own, like an exe file on the Windows machine. So some of those connections actually allow you to run a command, so any command you'd like, on somebody's laptop. And you can use it, again, pick it up and use it from the default environment, and you run and you move laterally to the machine. So this is actually one of the major things that we see again and again happening with these overshared connections. And one of the things that we did internally when we worked on this is to make our lives easier and find these connections is just create some tooling behind it. So one thing that we have here is a tool called Zapcreds. This is a very simple tool. You can find it at this address. Basically, you plug in a user for Zapier, and it will give you all of the connections that user has access to, and also show you which of those connections belong to other users. And we're actually expanding this to support other platforms as well, Workato, Power Platform, and many others. So yeah, feel free to check this out. One thing that up until now, we saw only cases where the connections were already available, but what if we want to entice users to create connections? What if we want to create basically a targeted attack within an organization to get users to log in, to share those connections with us? So what I'm going to show you is exactly that. Basically, these applications that are built on top of low-code, no-code, one of the key things behind them is that they operate on the vendor's cloud. And so, for example, you can use Office 365 low-code platform, which allows you to create applications in a Microsoft domain. So they'll be trusted by your users. And the users will automatically be authenticated with their Microsoft accounts. So here's a nice little app. I'm going to pick up an application out of the marketplace. This is going to be an application that basically facilitates an out of office. So it says your out of office message, it declines invites and so on. And so I'm just picking it up out of the marketplace, and I'm going to apply one simple change where that application, of course, has access to user emails, right? So I'm going to apply one simple change, which is using that email to pawn the account, to basically, in this example, just share an email, use the user's email on their behalf without them knowing. Again, this is just kind of a simple application I took off the marketplace. And what I'm doing here, every application could do that, right? When an application has access to a user's credentials, it can use it for whatever it wants without the user knowing. And you can see here exactly what I'm doing to add that kind of malicious line. It's one line of code. The crucial piece here is that this is very simple to do. This is running on Microsoft on a Microsoft domain, and this is something that users would automatically trust. Now, okay, it takes me some time to type. So after I create that application, I embed my kind of malicious line in it. I save it. That's it. It's deployed. So there's no like CI/CD pull request, somebody looking at this, nothing like that. I share it, and you can see that I'm sharing it with everybody in the organization, which is a nice little feature to have, right? And then I get this URL that I'm going to plug in here with another user. When I use that user to log into the app, the first thing that I get is asked for credentials. We'll go into that in a moment. And that's it. I'm inside of the application. And of course, the application has sent an email on my behalf, as I've just shown. So this might have been a bit confusing. So let me take you step by step on what happened here again. I picked up a random application from Microsoft's marketplace. That application required access to email. So I used that email, rather than just to do what the application is doing, to send an email on the user's behalf without them knowing. Now, when I created I saved that application, which means it's deployed. which means I get a URL on a Microsoft domain that every user in my organization can use. And now when I use it in another organization with another user, the application sent out that email on the user's behalf. So again, this is not special to low-code, no-code applications, right? Every application could use a user's credential to do whatever it wants. But there is a difference, and the difference is in the way that these applications get access. This window that we saw when the user entered the application is not the typical OAuth window you're used to seeing, right? This is not telling you what permissions the application needs and asking you to make sure that you're giving it the right permissions. No, it's just telling you, hey, I need a connection to Office 365 and to Office 365 users. These connections are, again, those refresh tokens that we've discussed earlier. And so this is an unbounded permission. This has all of the permissions that Power Platform could ever want. And so there's when I create that connection, so if you examine the token, you'll see that it has basically all of the available permission set. And so once I click allow here, the application gets my refresh token, and it is able to do whatever it wants with my Office credentials. Now, the title here is interesting because what I've basically done here is created a way for us to bait users to give us their credentials inside of an organization, and the only thing that protects them from falling in my trap is clicking that allow button, right? So they go into a URL which I provide, which is in a Microsoft domain, and then they click the allow button, and that's it. So can we get rid of that allow button? That would be terrible, right? Well, that's also available as part of the platform. So this is actually a flag that admins can just turn on, which removes this window, removes friction from adoption of those applications, but also makes it so that the only thing I need to do in order to own a user's account is just to get them to click on an email on the URL that is in a Microsoft domain. Okay, so we saw leaving of the land attacks for lateral movement, for privilege escalation, for ransomware, and for account takeover. The next part, and by the way, these are just specific examples, but there are many more. You understand the gist here. People are just using this to pick off credentials and be able to move across the organizations very easily. So the next obvious step is how do you stay once you've owned a low-code, no-code platform? How do you stay there as an attacker? And in this section, what I'm actually going to do is just show you what hackers have already been doing. This is a real example from an APT group about 2 years ago. This slide is from Microsoft Detection and Response team. The APT group owned a large multinational organization. They knew that they have been hacked, and they had teams looking for the hackers in their org for more than 6 months before they were able to kick them out. And the reason why it took so long is that instead of installing malware, moving through the network, doing the things that hackers usually do, they created an automation, a low-code automation that was used as their persistency mechanism. Basically, they created one single automation that ran on a schedule. On each time it ran, it used the e-discovery tools to search for passwords and PII across the Office infrastructure, and then send it off to an exfiltration endpoint. And because this runs on the Office cloud in an area that nobody monitors, that nobody looks at, this was running for 6 months. And so you can find all of the sources in this link of why this happened, and there are bits and pieces of information out there. So let's start with just doing what the attackers have done. This is a very simple automation. On a recurrent schedule, I'm going to list a SharePoint directory, and then I'm going to dump to encrypt any one of those files, to dump the encrypted files somewhere and tweet about it, because why not? Nobody will find me anyway. So this is exactly what the attackers have done, but this is actually this runs on a schedule, so this is limited. I want more than that. So here's one step better. This is the same kind of automation, but instead of running on a schedule, it runs off a call to a webhook. So now from the outside in, I can just call that webhook, and every time I do that, I'll exfiltrate the entire SharePoint site, which is nice. But if we're talking about persistency, we actually need much more. So here's a laundry list of the things we might want when talking about persistency. We want to be able to execute things remotely. We want to be able to run arbitrary payloads, which is not something we've seen so far. We want to be able to maintain access, even if the user itself is no longer accessible. Of course, we want to avoid detection and avoid attribution in case we get detected, and we want to produce no logs. So let's see how we can accomplish all of this with a no-code app. So this is actually what we've already seen. This HTTP hook is the persistency because we can just continue to call it even if we don't have the access as a user. These HTTP endpoints in all of the platforms that we've examined are hard coding some sort of secret in the URL, and so you don't have to be authenticated in order to call them. So here's an examination of what we wanted to achieve. There's a remote execution here, that's fine. Of course, this is not an arbitrary payload, there's a specific payload of dumping an entire SharePoint site. Being able to maintain access, I've already discussed this. Avoiding detection, I mean, this is pretty, I mean, in order to understand who is calling this endpoint, you need to be able to monitor those logs, and unfortunately, those logs do not exist. And more than that, you cannot attribute it because those endpoints can be called from wherever. In this demo specifically, I'm calling them using Tor. Okay, so logs, the last thing that I wanted to do, I didn't really cover it up until now. So these automations are generating a ton of logs. By logs, I mean, every time you plug in data into those automations, the data gets stored as part of the log. So this is very, very, very noisy, and this is something we're going to need to take care of. So here's another attempt. Instead of hard coding one payload, I'm going to hard code a few of them. So here are a few useful functions: linking an entire SharePoint site, storing attachments from Outlook.com, executing a SQL query, creating ransomware on top, basically encrypting an entire SharePoint site. So these are all specific payloads, and all of them can be called from a single HTTP endpoint, which is nice. And so for examining our list, actually, we haven't covered both of the things that we wanted to cover. Both arbitrary payloads. This is more than one, but it's still not arbitrary, and there are still logs. So let's see how we can cover both of these. And we're going to cover these with one little feature, which is awesome. And that is the fact that in all of the low-code, no-code platforms, one of their key features is that you can automate the platform itself with low-code, no-code applications. And so you have something called, in Microsoft, for Microsoft, for example, you have something called Power Automate Management, which allows you to create, delete, change, do whatever you want with the low-code, no-code applications as a low-code, no-code application. Okay, so you probably see where I'm going with this, but I'll take you through it anyway. So here's what we're going to see right now is also available. The source code is available in this address. It's called Powerful, which is kind of a pun over the Microsoft framework. And this is going to solve all of our persistency problems. And it's going to be pretty easy. So I'm going to start off with an HTTP endpoint. But instead of just using it as a trigger, I'm going to accept a definition of an automation. So just tell me what automation you want to build, with which connection you want this automation to be built. And then what this automation is going to do is create that other automation that I've just given it, run it, and then delete it, all at the same time, or kind of all in a very short period of time. And so I create the automation, I give it a definition, I can choose the specific connections, I can list which connections are available, so I can always be using fresh connections. And then I delete the automation. And the nice part about deleting the automation is that this also deletes all of the logs of the automation because they are stored as part of the automation itself, which is also pretty nice. This is the flow of what the tool is actually doing. And this is how the kind of very sophisticated automation looks like. Again, you can see this is all drag and drop, but this is kind of the advanced part of the drag and drop. And of course, because we are security professionals, we don't want to drag and drop things, and we want to look cool. Here's a CLI for you to do that with Python. Okay, so this was kind of expanding beyond what hackers have actually done, but recall that the basis here was something that we've observed in the wild. So the APT group has used this as a way to maintain their persistency inside of an organization, and it took the organization 6 months to find them there. So imagine what would happen with something like this. Okay, so we've seen how to basically stay hidden within those local no-code platforms. The last thing I want to show you is how you can take a look at how you can exploit local no-code platforms from the outside looking in. Because up until now, we've been discussing what users of those platforms can do. So you need to first own some user, which is admittedly not that difficult in a large organization. But still, these platforms also allow, we are also seeing hackers that are targeting basically public endpoints that these platforms are putting out on your behalf. So let's see a few examples of that. You know, before I give you a few examples, let's just recall that this is again not something that is special to low-code, no-code. If you think about S3 buckets, for example, in AWS, this is like a misconfiguration that we know that happens again and again, where those S3 buckets are exposed to the public. We've known about it for many years now. AWS has finally put in place things that are preventing it as a default. But it's still happening, right? It's still happening because it's a predictable misconfiguration, which is very easy to do. So the same kind of things is happening within those local no-code platforms. Let me give you a couple of examples. The first example I'm going to give is again about Microsoft. This is Microsoft has one of their features for their low-code platform on top of Office is called Portal Apps. Portal Apps is basically a public-facing application. It's used mainly to basically do things like onboard contractors or vendors or people that are coming to your office. For example, if you visit Microsoft offices physically and you need to provide a vaccination proof, you'll do that through a portal app. And so those portal apps, they are basically web pages with a managed SQL instance behind them. And so when you create a portal app, you get a dedicated web application. You can note the domain name. So something.powerappsportals.com. This is going to be fun later. And so these applications also have an API that is created for extendability. This API uses something called OData. It's always in the same place, so the same path. And why am I talking about these types of applications? Well, because the team at AppGuard, actually a year and a half ago, found that these applications, the default configurations for those applications meant that the API exposed all of the database behind the applications to anonymous users. That was the default. And nobody noticed that was the default for about a year until they did. And so once they did, they identified about 40 million data records that were exposed. And so Microsoft was then actually very quick to fix the default, but people are still making mistakes because it's difficult not to do it, not to make mistakes. And so let's see what we can find out by just trying to find those applications from the outside looking in. Here's one concrete application. This is a real world example. You can see that by going through to the OData route, I get a list of all of the objects that are available for me to query. The default and the entities form set objects don't have anything interesting, but you're also seeing the global variables object, which is interesting. And when you query the global variables, I'm sure you'll understand what you're going to find. Authentication tokens to Azure, which is kind of nice and available for you out there. This is a real example from a large financial services company. Of course, we've disclosed this vulnerability to them, and they fixed it. And so this is one example, but the question is, can we find those problems repeatedly from the outside looking in without knowing that this specific portal exists? And here's the clue of how we do it. This is very simple subdomain enumeration. All of these apps are using the same domain. And so here's a very lazy way to do subdomain enumeration in a Microsoft product. You just use Bing. It works pretty well. And so you're seeing the amount of results that we got here. You've seen a few examples before, kind of on the last slide, but we found a bunch of PII. We find lots of secrets. We found a lot of business data, so PDFs, contracts, vendor lists, all sort of business data that was out there. And of course, we disclosed this, but this is just an example of a kind of predictable misconfiguration that can occur, and it's very, very easy to exploit. So let me share another example of the same kind. So this time, instead of just picking on Microsoft, this is Zapier. Zapier has a nice little service called Storage by Zapier. Basically, Zapier is an automation platform, and if you want to maintain any sort of state in your automations, you need a store, right? You need something to store that state in. So they have a key value store which they provide for you, and you can use it to hold state or secrets or whatever you'd like, which is pretty nice. The way that it's protected, this key value store, is with a GUID. So you provide a secret, and that secret allows you to do whatever you want with the key value store, with the keys that you own. And the secret has to be a GUID, which is, I mean, it's fine, right? It's not perfect, but it's fine. When we looked at this, we looked at the actual API documentation, and you can see when you call the API, you get a bunch of kind of text, but you also get examples. And you can see the examples on the upper right side. They use secrets that are very much not a GUID. So this kind of triggered us. And so we just started by plugging in this specific secret that they have in their documentation. And voila, we found we got access. And so we just did a very simple dictionary attack and was able to uncover that this is not just one example. There were actually a bunch of those examples. And those examples, when I mean an example, basically a secret that revealed the key value store values to us. By the way, we could have also changed them, deleted them, and you can see the types of things that we found here. And actually, working with the Zapier team, what we've discovered is that today they force you to use GUIDs, but they didn't used to do that up until two years ago, and they simply never did anything with the old secrets. So they are still there. So you can reuse them, and then you're not secured. So again, this is a very easy example. You can very quickly enumerate this from the outside looking in. Imagine the business user that used the secret equals 1, 2, 3, 4, 5. They don't really know that it's insecure, and it's really not their job to know that. Okay, so I'm going to pause for a bit, and let's do a quick summary of what we've seen so far. We've seen that low-code, no-code is huge in the enterprise, and we've seen the ways in which it's a bit underrated by security teams. We've seen the ways that attackers are taking advantage of it with living off the land, hiding inside of those platforms, leveraging predictable misconfigurations. You've also seen two tools that you can use as part of your education process. There are others. I encourage you to look at the links. There's a link in the last slide with a bunch of tools that you can use. And the last thing I'm going to do before we finish off is just to give you a few tips on how to stay safe, or what can you do to basically onboard low-code, no-code into your application security mandate. So Some of these things here are very concrete, but others are more strategic. In terms of concrete things, you need to review configurations. So you need to be aware of the platforms that are being used inside of your organization. Specifically, look at the bypass consent flag for Microsoft, which allows users to create these bait applications. Look at connector usage and make sure that you're limiting which connectors can be used. Monitor those endpoints. You need to know which external endpoints are being put out by those platforms on your behalf. Of course, review the shared connections inside organizations. I can't tell you how many organizations just started a conversation with them. The first thing we did is I told them, okay, go to this address, look at the shared environment, and we are seeing SQL servers and FTP servers and shared Teams tokens and whatever you'd like. And from a more strategic perspective, check out the OWASP low-code, no-code top 10. That should give you a framework on how do you think about low-code, no-code, and how can you take it under the application security umbrella. Thank you very much.
Okay, Michael, I have a question to start with. And sorry, you want to start off? Yeah.
Yeah, we've been working with Microsoft on this for a couple of years, and we're really pushing them to change things. The fact that the connectors are so hard to trace, the fact that they have so many permissions, the fact that it's very hard to audit the permissions. There are other things you can do as well. You can set the DLP to make sure that your business connectors and your other connectors don't mix. You can set policies in cloud app security. You can monitor the audit logs and the Office activity logs in Sentinel. So we've been monitoring these things and detecting these things, but we realize that it is a huge task to do. So thank you. It's a very interesting talk. Thank you.
Thank you. I'm glad to hear that you've been working with Microsoft on that. By the way, this is not a diss on Microsoft. They are doing they're doing a good job, but this is still limited. And some of Microsoft's teams are actually part of the OWASP group, so we're working together with them. One thing I'll note on the Power Platform DLP, which is important to note, today we know of 7 or 8 ways to bypass it. Those are really simple, like for example, instead of plugging in the URL, which can be filtered, just put it in a variable and then they cannot filter it. So it's very basic.
They're making changes.
Hopefully soon. Okay, Michael, I have two specific questions I would like you to clarify. I'm sure, I have this doubt, and maybe the audience has a similar kind of doubt. So who's actually responsible for a low-code, no-code application? One is that. Very simple question. Second is, what you feel is the difference in terms of securing a low-code, no-code application vis-a-vis a traditional commercial application that we look at?
Okay, so the first question is the most challenging. We are used to working with, as application security teams, we focus on applications that developers are building. And that has been fine up until now. But the rate at which these applications are being built by business means that in a few years, this is the mainstream, not what we are doing. You saw the chart. There are the numbers, like 70,000 different applications. There's no way for developers to create the same kind of amount of applications. And so we have to be in charge there. We need to help those business users build those applications correctly. And if we don't put ourselves out there, they're just going to do it without us. And this is going to leave us A, exposed to risk, and B, a bit irrelevant. So we really have to get going there and to be part of the conversation. In terms of how different this is from what we've been doing, the most important thing to understand about low-code, no-code in terms of kind of technically is that you don't have any of the fundamental building blocks you're used to building your security strategy on. There's no code to scan. There's no runtime logs or no way to plug into runtime. There's no CI/CD in most cases, and there's no security savviness from the side of developers. So you need to really reinvent the way that you do application security.
Okay, we are open to any other questions. Do we have any? or it's been too heavy for us? Yeah, we've got one.
Just a short question. On your slide about Zapier, it said $400 bounty. Is that all it gave you for?
Yes, and we've actually found on the same week we found a sandbox escape, and they gave us $300.
Calls for a party then.
Yeah. My question is, how can we communicate to colleagues building those apps about the security issues they might not be aware of? Because, you know, as you just showed that, it's all GUI, and you can just click and play. How can we communicate to them the security implications of building such tools?
I find that the easiest way to communicate the risks here is just to show them. So here's a way to drag and drop information outside of the organization, and then they all of a sudden get the realization, or here's a way to impersonate another user, or to create an application, embed your own identity within the application, and then everybody can impersonate you. But this is a conversation we need to have with business leaders. In most cases, from what I see, business leaders understand, the people that are managing those platforms, the admins of those platforms, they understand that security is important, and they do whatever they can in order to secure those applications, but they don't have the tools. And they also, to be frank, they kind of just do what the platform tells them to do. So the platform gives them best practice, they follow the best practice, that's fine. But there is a shared responsibility model here, right? You cannot really rely. Some of the vendors are still in a mindset where they're telling their people, hey, everything you're building on top of these platforms will be secured. This is not going to happen. There's no way. We've tried that in cloud. We've tried to say that AWS is in charge of everything we're building in cloud. That failed dramatically. There's a shared responsibility model, and we own part of the responsibility. The same thing happens here. Just today, in most cases, we simply don't do our part.
The most favorite topic, I guess, for each security team. How do you manage asset inventory for low-code, no-code apps?
Okay, so here I have somewhat better news, because these, before low-code, no-code, business users have been doing whatever they wanted, mostly through copy and paste. So there's this nice little phrase I heard once, copy and paste integration. This is what people have been doing, right? And we've been trying to get a hold of it, shadow IT, DLP, all sorts of this. We haven't succeeded in doing that. When people start to use low-code, no-code platforms, you end up with APIs that you can just ask questions. And you can ask a question like, what are all of the applications that I have that were built on top of Office 365? Now, of course, in those large numbers, specifically with Microsoft, inventory is not easy. Even if there's an API, it gets flaky when you get to over, 1,000 applications. But there are ways, but there's, at least there's someone to ask that question.
Yeah. Do we have any more questions? Okay. Thank you, Michael. And great talk.
Thank you.
This topic is very nascent to most of us, actually. And to learn and grow into this particular field, it's an ask. And I'm sure some thoughts would have come to our mind after listening to him. So great talk, and request for a round of applause for him, please.